Okay, it's live now. Okay, so we did a lot of stuff on Tuesday. Do you guys check GitHub? Do you see the integration with GitHub? How I did it? If you come here to our channel here, we see that my first commit was here. Okay, so we have here first commit. This is the repo, right? And you can find the source, the code here. If you just click here, you see that the code is right there. Okay, so you can see the code here. You can copy from there. You can clone it to your machine. You can fork it, right? You can fork it to your repository, to your account GitHub by clicking here, this fork here. Okay, and you will be able to see everything that we did on Tuesday, and it's gonna get much bigger as we go. Okay, but it's gonna be in this section here under this repository, Java certification 1Z0-808. Okay, so everything's gonna be posted as soon as I commit it to GitHub. It's gonna show here, right? So you guys, what you have to do is just see this is what we covered on Tuesday, and then click on one new commit, and it will take you there. If I click on that, it will take me to a comparison or a detailed view of that. What you guys have to do is just come here where it says code, right? And then click on source. And that's it. That's where the code is. Okay? So always click on code. Code is the place where you can see the code. These are files that are, committed by the IntelliJ, right? Things that have to be there for the program to run. So if you do it, just copy the code. Don't download, or maybe download the entire thing and run it on your computer. But you need these files to be able to run it on IntelliJ. Okay? Good. Any questions about GitHub? No questions? This is where you find it, okay? All this is pinned. Okay? I'm not pinning this because we're gonna have a lot of this message, but I'm pinning the information of the channel where you can watch the videos, right? Every class we are recording this video, and you can click on this. This is the channel, or you can click here, whatever you want, okay? And then you can subscribe so you can be there and have it, as soon as we post something. Okay? No questions? No? Okay, so it seems that people probably panicked. The first day of class, we only have 13 people, and this class is like 25 students. Okay. All right. So we continue. We're gonna talk about naming conflicts, and code formatting. Okay. So let's create the first program under the package Learning Java, MDC.Learning Java. We're gonna create a class, right? And the class we're gonna call it conflict example. Okay. We have a class here, so we do what we always do, PSVM, and then we just have this main method that is used to run the program, okay? So before I do anything, I just want to put the comments that I always do, right? And I'm gonna say maybe just the author, if you want to do it this way, say Duniez Quintano, and then today's date on, today's 8, right? 10/8/2020, right? Right. Good. So now I want to create a method, right? I want to create a method, and this program is just for you guys to just understand how formatting works and some naming conflicts that we can have. We're not going to run this program, okay? It's just for you guys to see some of the problems that we may have along the way. So I'm going to create here maybe this. I'm going to create this variable. This variable. Date. Okay. So that's a type, right? That's a type. And then we have to import that class. So we import the class, and it's going to be this one, right? And then we just imported this class. Because to be able to use the class date, this is a built-in class like we spoke about, like we said on Tuesday. The R classes are already built in, so date is one of them. Okay, it's a type and it's a class. Okay. And now I'm going to just write maybe this one, right? And then have this, another variable, but we're gonna call it SQL date. Okay. That's another variable. All right. Now we have this guy here, right? We have this guy here, and then we can easily, you can write this guy like this, right? Right? And then we can import all the classes that are in this package here, java.util, and then dot whatever class you have after that. And one of the classes that we have there is this one, right? Now we can import this one as well, right? And say this one here, say this, right? And then put the import. Right? And then here put date. Right? So we can do that too, but you know, it immediately make the other one disappear, because now, for example, if I do this, right? Let me bring the other one back. If I do this, right? It's gonna be confused because it doesn't know which date it is. You see the problem now? You see, we get an error here because after this dot, we have date. Okay, we have date, and then it disappears, right? So to avoid that type of conflict, because now compiler doesn't know which date we're referring to, right? There are two different packages, right? One is java.util and the other one is java.sql. So it doesn't know which one to use, right? So what we can do to avoid such a problem is just put the package here. So we're gonna do this, right? And then here we do this. And then problem solved, okay? So these are some of the naming conflicts that you may have in your program, okay? So it's better to use when we have two classes that are the same, but different packages, right? Different packages. The best thing you can do is just use the package then, and then there will not no conflict. There will be no conflict, and compiler will be able to determine what date you're referring to. So the variable doesn't matter. The name of the variable could be anything. It could be my date, right? It could be my SQL date. It could be any name. What matters is this guy. The compiler, when the program is run, it will not understand what date you're referring to. So again, if you see that you have the same class here, but different packages, write the entire package. Don't write just date like this, because it's gonna get confused. It doesn't know what class you're referring to. Okay, that's one thing. So we put it this way, and then we solve it, right? Now let me create another method, right? Remember the method has an access modifier. It can be public, private, default, or protected. Okay, so with this, we just put the return type. We're now returning anything. Okay, so now we're gonna see the formatting. Sometimes we may have some formatting problems in the exam. They may put a few syntax structures in the same line to confuse you. Okay, so when that happens, what you have to do is write it on a piece of paper and try to format it on a piece of paper, because you're not going to have intelligence in the exam. So here we can do just press some keys and format this guy. But in the test, you cannot do that. So they may try to confuse you. So let's go the method check empty. Okay, just one method here, any name. Okay, so we're going to put list. Okay. Okay. By the way, list is a collection. Okay, it's a collection of elements of similar types or different types. Okay. Let me say if list, we take the variable, right? If list is empty, it doesn't work, right? It doesn't work. Why? Because we have to import this class, right? So if you hover over it, it tells you import class, right? So you import it, and then we're gonna do this one, and now it works. Right? Now if we do this list, then you get those methods. Now, what if we do this? It works the same, right? Right? Because we're just bringing every class after this. So we're bringing list as well. So if we say if list is empty, right? And then they may do this in the exam, right? Usually we do this, right? But in the exam, they may do this. Okay, and then right, and then put else here. Okay, and like that, and then print not empty. Right, and just close here. Okay, this syntactically is not incorrect, because you can put things in the same line. Okay, but it may confuse you because maybe you're more used to see this. Something like this. Let me see. Okay, maybe you're more used to see that, because this looks better this way. Okay, and you can do that in Windows with Control Alt L. I think it's L on Windows. Okay, try that. How to format in IntelliJ on Windows. Okay, so again, you must see this guy, right? This is more organized this way than the way it was before. So if we do go back, and then we have this is less organized, still works, but it's not as organized as if we do this, for example, and we have this organized. Okay, formatted, clean. Okay. Of course, this is the way that a list is just put. Okay, so list has a parameter here. It could be a list of strings. It could be a list of you know, a list of numbers. If it is integer, then you put it this way, integer, you know, and then you're having a list of integers. But just for the sake of this class, I'm not going to put anything, but just understand that this is a raw way, like the arrow says, this is a raw use of parameterized class list. Okay. Always when you see list, you will see this. Okay. Or you will see a class. For example, remember we created a class named person last class. It could be a list of objects. Okay. Instead of a list of numbers, it could be a list of objects of the class person. Okay. For now, let's leave it this way. Okay. Another example, you see that here we have the main method, right? It's right here. And we have another method. It's like I said on Tuesday, methods cannot overlap. Okay, so we have to get out of the method to create another one. So we're going to create another one, right? And then I'm going to say, actually, I'm not creating a method. I'm going to create a class. Okay, not a method, a class. Of course, we have to get out of the class, right, to be able to get another class. Okay, so we're going to say public class, line numbers, and then we say like this. Okay, I'm going to do it this way. Okay, public class, and then we can say public void check empty. Okay, you're just calling that method. Okay, and then we say list, and we say if list is empty, then you must see again the same problem, sysout, right? Of course, IntelliJ will put it the best way possible, but in an exam, in order to confuse you, they may put it this way, okay? Empty. Else, and then we put this again, and they say system.out.print, and they say not empty. Okay? And then you close this guy. Okay? Of course, you have to close this guy too. Okay. I put a semicolon there. When you put a semicolon, it means that the line ended there. So it means that whatever comes after that is unreachable. And else and if they are connected one way, they work in conjunction, right? So they can put this way, and then in the exam they will try to confuse you. But don't forget that this works. They just put it in the same line. Okay? So what you have to do is format it in your head, just put it on a piece of paper, and put if, right? We're gonna see if statements. This is just for now to see how conflictive something can be if you know, if they put in the same line and you may be confused in the exam. We don't want that. Okay. All right. So this is all about naming and formatting for now. Okay. But guys, understand that here the compiler needs to understand what date you're referring to, because you have two classes named date from different packages. Okay. Don't forget that I have a class here import. You see my class import example? I have the same class here. You see? Because they are in different packages. They don't conflict with each other. Now, if I try to put this class here, it will tell me that the class already exists. This is exactly what is happening here. We have the same class, in different packages. Okay, so compiler will get confused if you do this, right? It doesn't know which one you're referring, if it is util or if it is SQL. Okay, so it's better to put it this way, and there will be no confusion. Let me delete this guy. We don't need it. Okay. Do you guys understand?
Yes, that's clear.
Yeah.
Yes, yes.
Can you use one or the other?
Which
Or
one?
you just use that as an example, right? You could, because you could use java.util.date or java.sql.date.
Depending. This is for the database, right? And this is just for date. Right. Here you have SQL. SQL is a database.
So that's okay. So the SQL is for a database.
Correct.
Okay.
When you're working with dates in a database. Okay. Now, yes, compiler will get confused because we have the same class name. Okay. Now, that's all for that one. Okay. Let us create another class. Okay. And let's name it this. Okay. Let's just create another class and just give it a name. Let's name it whole. Okay. Whole numeric primitives. All right. Guys, what is a primitive? Okay. First of all, what is a primitive? So what is a primitive? I have here this question here. What is a primitive? Okay. A primitive is a data type size, right? It can hold values, right? Key points, right? That's a primitive. It's a data type. Now, these are some of the examples of primitives. Let me put it here. All right. So some of the primitives are Boolean, which is an example true, right? It doesn't have a size, right? It's just true or false. Right? So we have a byte, and a byte has 8 bits, right? And that's what you see in, for example, in a public IP address, right? In an IP address, you see that has 4 bytes, right? And every byte has a bit, right? What is a byte? For example, one can be a byte, right? Short is another data type. It's a primitive, data type primitive. And it has 16 bits, right? And 12, for example, it's a number, 12. It's a short. And you can have an int, which is an integer, and it has 32 bits, and it has a number, for example, 100. Okay. Now, see here that these guys that just, increment by the double, right? Let's just multiply by 2. 8, 16, 32, right? Now we have longs, right? A long is a 64 bits number. It's a super long number. And by the way, when you create a long variable, you will have to put an L after the value. Like something like, can I tab here? Like an L. I will show you when we get there, okay? And then you also have float, which is a decimal here, right? It has 32 bits, right? And you have to put an F after the number, okay? If you don't put an F, then you get an error. And that's one of the questions that I may ask you in the exam. They can put a float and just a bunch of primitives and ask you which variable declaration is valid. And they can put a float without an F and a long without an L, okay? And then that's not valid, okay? And then we have 123.45, and then you can have a char, right? That, well, actually, this is a double, 64 bits, it's bigger than a float, right? And also a double, you can put a D if you want to, but it's optional. You don't need that with a double. So if you see a number that says double, and then the name of the variable and the value has a D at the end, that's valid, okay? But it's not mandatory. For the float and the long, yes, it is. And then you have char, which is 16 bits. It's only one character, okay? So if you have AB, it doesn't work. That doesn't compile. It has to be only one character, either A lowercase or A uppercase, okay? So at least you have an idea what a primitive is, right? Where's hold on a minute. Okay. So let's see this. I'm going to create the main method. Okay. Right. Now I have the main method here. So I'm going to create a file, and just a file, not a file, a variable called max. Okay. And that's a long. Okay. So I'm going to do this 32. Okay. 123, 456, and 789. Okay. By the way, this is a way to just, make the number more readable. Okay. You can put 32, 123, 450, and this is valid in Java. Okay. This is valid. Now, we're getting an error here, and that's exactly what I explained before. If you don't put an L here, then you get an error. Okay. This will give you an error. So this L is mandatory, which indicates that this variable is a long. Okay, it's a long number. Right? Now we're gonna put another number, and then it's gonna be n, right? And then we're gonna put 3,000. Now the question: why does this one compile if it doesn't have an L, and this one doesn't? If we remove the L, you can put an L here, and it works, but this one doesn't work. Okay. Have you seen the size of this number compared to the size of this one? Okay. Because this number is a very small number, right? We can use an int here. We can use a double, right? Well, double, you have to put this to be able to make it work. Well, actually, I'm just missing the variable name, right? So a double is here because, a float, a long, right? Because an int will be promoted to a long. That's why it happens. It's a short number, right? The long can cover this number, small number, so you don't need the L. For this long number, yes, you would need a long because this cannot be an int. This is too long for an int, okay? But in this case, it works because it's a small number. Now we have something called in Java octals. So an octal number, okay? Usually octals, they go from 0 to 7, okay? That's an octal number, okay? So now we have int here, and we say oct equals 07. Okay. Okay. We get this number here. Okay. And then if we print oct, and we do this, we get 7. Okay. So you may see a number with a 0 in front of it. That's an octal number. Okay. Now, if we Google the list of octals, okay, octal numbers, okay, Why is this so slow? Okay. So we have here so it goes from 0 to 7 octal numbers, and then it jumps to 10. Okay? So a decimal will be 8, right? Decimal will be 8, and then the octal will be 10. So if we put 0, 10, right? If we put here int first oct, for example, and we do 0, 10, right? Guess what's going to print? If we print it, what are we going to get? 8. Okay? Because the representation of the decimal 8 in octal is 0, 10. Okay? We have to put the 0 in front of it because otherwise it thinks it's an integer. Okay? But it's an octal number. So if we do now, we just print this and we say first oct, I'm sorry, and we print this, what do we get? Number 8. So those are octal numbers. There's a table for that you guys should consult when you have some times, that there are numbers that are called octals numbers. They're used in Java, right? And then it begins from 0 to 7, and then it jumps to 10, right? And the table goes on and on and on. Okay? So what if we do, for example, 21, right? And then we print it. So we get 17, right? Because this list continues, right? 11 is 9, 12 is 10, 13 is 11. You know, this way until you get to 21 is 17. Okay? So don't forget that, guys. There's an octal number. When you see a 0 like this, a 0 in front of it, that's a number. So this returns 7, right? And this one returns 8, right? Let's do another one. So we have int second oct, right? And then we say 0.22, 22. And then we close this and say this returns what? Let's print it. It returns, oh, we haven't printed it yet. Sorry. Second int. And that prints, second oct, it prints number 18. Okay? So that would be returns 18 decimal. Right? This one returns 7 decimal, 8 decimal, and this one's 7 decimal. Okay? So we can make this a little more beautiful. We can just, maybe we can sum. You can add both octals, or maybe, yes, first and second, and we can say sum of octals, right, equals first octal plus second octal, right? And then we get a sum of the octal, right? Now, we can print and say, for example, sysout, right? And say first equals, and then we say first octal. And then we say plus space second, and then we say second octal. Okay, that will be one print. Second print, we can do this, and we say decimal sum, right? And we can say this, and we say sum, right? That's the sum, but we're printing the decimal sum, okay? Now we're gonna print the octal sum. Okay. And then we say this. Integer dot to octal string. And then we put the sum inside. Okay, so let me delete this. We don't need it. Or maybe I'm not gonna delete it. I'm gonna put the comment just to comment it. Okay, nice. Now, what are we doing here? Okay, first, we are printing every octal except this one here, because we know that this one's 7. We're printing this first and the second, right? That will be this line here. Then we are printing the sum of the octal, this sum and this one, and how much you think it's going to be. If you sum this, right, it's going to be what? How much is 010 plus 022? Guys, are you here?
032, right?
Okay, let's print it. Okay, let's print it. So what do we get?
Oh, just 32.
Okay, so here we are returning what? 8, right? And
Right.
here we're returning what? 18. So when we sum these two, we get 26, right? But this can be converted to octal, right? And then we use this method that the class integer has. And by the way, this is a wrapper class. Wrapper. It's called wrapper class. It's the wrapper class of int, right? Int is a data type, and this is a class, right? Whenever you see blue like this with capital letters, that's a class, okay? So we are converting the decimal, which is 26, into an octal. So how do you put octal like this? It's going to be 32. Guys, if we print, let me have here int second, third, oct, right? And we say 32, right? And we print third opt, right? We're going to get what? We should get 26. Okay? So we're adding these guys because each guy here returns a decimal. And the decimal is 8. And this guy, the decimal is 18. A plus 26 is 26. Plus 18 is 26, right? But then we convert that into an octal, right? And we call this method, right, from the integer class, and we pass the sum that is right now in decimal, we pass it to convert it to an octal, and that's why we get 32. Okay. It's just inverse process. It's like moving from an integer to an octal. And this is plain English. We're saying to octal, right? From an integer to an octal. And we're passing the sum that is right now in a decimal, which is 26, right? Do you guys understand so far?
Yes, yes.
Okay. So now let's continue with the hexadecimals. The other numbers are hexadecimals that go from 0 to 9 and A to F. Okay. If we take a look at hexadecimals, right? And we have here maybe a table. We'll find a good table here. Maybe Wikipedia. Okay. right here. Okay. So it goes from 0 to 9, and that's the number. And then 10, it begins with 10 is A, 11 B, 12 is C, 13 is D, and then it goes on and on and on. That's the hexadecimal number. You guys can convert, just look for the conversion of hexadecimal to decimal or vice versa. Okay, and then you can understand that a little bit better. For now, we're going to use the hexadecimal here, so decimal, right? Which is from 0 to 9 and A to F. Okay, hexadecimal. Now let's declare the first number. Let's say first hex, right? And we say 08F. Okay, so that will be a number. Okay, that's a number. It's hexadecimal. Now, guys, I don't have. I mean, maybe you can remember that it begins with 0x, right? And then a letter. But guys, you will have to remember this, okay? This is something that, you know, you have to at least have an idea how it works to be able to identify, because what they do in the test is give you something similar and ask you if that's valid, okay? And you will have to understand how you put it in Java. Like now, for example, this will return a number in decimal. This returns 15 in decimal. So that's the number 15 in decimals. All right. Now we have another one, second hex. Okay. And we're going to say 0x1e. And now I'm not going to say what it returns. We're going to see it. Okay. And now I'm going to do the sum of both. I'm going to say sum hex, right? And then I would say first hex plus second hex. Okay. And that's going to print the sum of those numbers. Okay. Now, I'm going to do sys out. I'm going to say first equals and then plus and say first hex, right? And then second equals and then second hex. Okay. So far so good. Okay. So now let me run this for you guys to have an idea what it prints. So we see that the first one is 15 and the second one is 30. Okay, so this number here is 30 in hexadecimal. Okay, this returns 30. Okay, it returns 30 in decimal. Okay, and this is the sum. So we are summing, adding these two numbers, we should get 45, right? When we add them all, both. So now I'm gonna print the sum, right? So we can say decimal sum. Sorry, I forgot to put the quotation marks. So decimal sum, right? And then we say plus and say sum hex, right? So we're adding the hexadecimals and we store that in a variable named sum hex, right? And now we can do hex sum, right? And guys, guess what we're gonna do now? Guess. Do you think it will be similar to this one? Because we're converting from decimal to hexadecimal. Do you think it's gonna be the same as this one or similar?
Similar.
How about that?
Yeah.
Yeah, so we say integer. And then we say to hex string. You see here? To hex string. Then we pass sum hex, right? So we are converting from decimal to hexadecimal. we're converting from decimal to octal. Okay, and we use this method called to hex string. All right. Now, if I run this, we should get something like this. Okay, so the sum of these two numbers is 45. That's the decimal, and this 2D is the number 45. We can just test that, and we say int, right? Hex, I would say 2D, right? Yeah, it's literally written this as a double, but right. So that's what we're doing. This 2D represents. Maybe we can Google that. We can say 2D in decimal. 45. You see, 2D in decimal is 45. Got it? That's what we get here. Do you see it, guys? Do you see it? What we're doing here, right? So this is another notation for numbers, like octal, decimal, binary. There's another one, right? Binary. So different ways to express a number, okay? Depending on what you're using it for, right? Usually binary is for IP addresses, right? For IP addresses and to convert, you know, like letters text to binary. Remember that a computer doesn't understand numbers. A computer understands 0011100. Sorry, not 2. 00111110011111100. This is what the computer understands. The computer doesn't understand anything. So, for example, letter A in binary would be 01000001. Letter B is 01000001. Now, maybe the question is, where am I getting this from? Well, pretty easy. Every letter, every character in your keyboard has an Ascii code. Okay, Ascii code. There's an Ascii code table, right? That you can see maybe here. This is an Ascii code table, right? That has decimal, hexadecimal, octal, HTML, and character. So, for example, 0 would be in decimal 48, in hexadecimal is 30, is 060 in octal. A, for example, is 65, 41, in hexadecimal, octal is 101, okay? And that would be A, okay? So maybe if we do this, maybe, so maybe, right? Now, if I print A, right? What do we get? We get E. Okay. You see E here is 101. Okay. And there's every single character has an Ascii number. Okay. This is the Ascii code. And that number is changed to binary. Okay. So letter A 65, right? If I do 65 in binary, right? 65 in binary. It will be this one. It's the same as what we had before, letter A, right? and that gives us the number 65. So that's what happens in hexadecimal, and you can express that in Java as well. Okay. So now let's do another one. Let's do binary. That's the other one that we were talking about. So far we're seeing octal, we're seeing hexadecimal, and now we're seeing binary. Okay. So I can say int, right? First binary bin, and we say 0B 1001 is to 0, 1. Okay. So now okay, so we have this binary. It's like we saw here, right? That's the way you wrote binary. That's B stands for binary. We have another number. Let's see, int second bin, right? And we say 0B 0111. Okay. And now we say int sum bin equals a first bin plus second bin. Okay. Okay. So now we can print this. So we say sysout, right? First equals first bin plus second equals second bin, right? Then we give you the value for each one, for the first bin and the second bin. Okay, now we say sysout, and we say decimal sum equals sum bin, right? And then we say bin sum equals integer, and then we can do the same thing, but now it's going to be 2 binary string, and then we pass the sum bin, right? Similar. So we are changing, we are parsing this number into a binary. Now we do this and we run this, and we get that 16 is 10000. Okay, the first one is 9, right? So this one returns a 9, and this one returns a 7, right? This one returns 16, and this one returns 9 plus 7, which is 16, and 10000. Okay. In binary. All right. Binary is the language of the machine. The machine understands zeros and ones, zeros and ones. It doesn't understand 9 or 7 or 16. It understands this number. Okay. That's what the machine understands. Right. So we can have this, for example, a third, an int, for example, third bin, right? And we can do this 0b2, right? This doesn't work. Okay, this doesn't work. Integer number too large. So if you see this 0b2, that doesn't work, right? That's not binary. Okay, so this does not compile. It has to be this way because this number doesn't exist in binary. Okay. So guys, do you have any questions? No questions? Are you understanding the types?
So far, so good.
Understanding the types, how you can add, octals, add hexadecimal, and add binary, and then convert from octal, from decimal to octal, from decimal to hexadecimal, and from decimal to binary using this method here. Okay? Don't forget that. So I can say here, let's convert decimal to binary using method, okay, to binary string, right? And pass the sum bin, okay? The sum bin value, okay? Very important that you understand that, okay? Let's do the same here. Let's convert decimal to hexadecimal using the method hex string and passing the sum hex here. Okay, let's do the same here. Let's convert decimal to octal using the method to octal string and pass the sum oct value. Got it? So far, so good? Guys, look alive, please.
As clear as mud.
As clear as mud. Okay. It doesn't look clear to me. All right, good. So this is how you do that. That's whole numeric primitives, okay? Now let's talk about decimal numeric primitives. Okay? So we have another program that is anyone typing something on Slack? Okay, no. Okay, so let's create another class and let's name it decimal numeric primitives. Okay. Right? And now we have our dear friend, the main method, so we can run this. All right. So let's create a float. Remember the float that we saw here in our beautiful, where is it? Beautiful here, a float, right? That has 32 bits and it's a decimal here. Floating point, right? So let's create a float here and I call it my number, okay? Now remember that with the float, we need something, okay? So this will give us a problem. We need to put a character here, say F. So we have to let compiler know that this is a float by putting the F at the end, okay? So let me give you some examples of things that don't compile, okay? So this one, if I say double before, for example, double before, and I do this 10, and then we do this doesn't compile, okay? Remember that we saw before, we saw that this number, we can put this, okay? But in between the numbers, not here like we're doing here, before a decimal point. That doesn't compile, okay? So let me comment that. This does not compile, okay? Very important. Another example is, let me put it here, double after, right? And let me put, because before we put in this underscore before the decimal point, right? Now we're gonna put it after the decimal point. This doesn't compile either, because you cannot put underscore after or before a decimal point, okay? So that, and why am I telling you this? Because in the exam they can put it and confuse you. Okay, so that doesn't exist. That doesn't compile. This does not compile. Okay, very important that you guys understand that. Now, I'm gonna say double first, right? And I'm gonna put this underscore 10.25. This doesn't compile either, okay? Because you don't put that when there's a decimal point, okay? So you don't put it after or before or first, right? Or even last. Okay, we're gonna see last now. So this does not compile either, okay? This does not compile, right? And then double last, you say take 0.25 and then this. This does not compile either, okay? So keep that in mind. These 4 examples don't compile any of them. So this does not compile either. Okay. Now let me create a double, and let me create a real one that compiles. Okay, my double, and there's 2.54. Okay, that one compile. We can do this, which is optional. We don't need it with the double. Okay, so let me do this. Okay, and let me put it here. Right. Let me remove this and say this does compile, but the letter D is optional. Okay, good. Now this, my double, equals 254, 2.54 F. Okay, so I'm gonna put it here, different name. This compiles. Why? Because a double can be promoted to a float. Okay, or a double covers a float. Not is promoted to a float. A double is bigger than a float. If you take a look here, where's my? A double is bigger than a float. Okay, so a double covers a float. It's like if I do this, double, my double, 3. If I do this, it works. And this is an integer, right? Because a double, an integer can be promoted to a double. A double can cover that integer. Okay? So all of these guys, they compile. Okay? They compile. So this, okay, let me, one moment. This compiles. This compiles. Okay? And this compiles. Okay? Good. Now this, right? This scientific, for example, scientific, that's just the name of the variable. It could be anything. 5.00012.5E03. Okay, that compiles. Remember when you have a long number and then you have this E in the calculator? That compiles. Okay, now this guy, right? Scientific 2, right? This guy is exactly the same. They express the same thing. Okay, so another way to express the same thing. Okay, either putting a 0 after the E or not putting a 0 after the E. Okay, have the other one. Maybe my double 3. I already have my double 3. Maybe scientific 3. And then I can say 5,000.125. Okay, and this also compiles. Now, if we print the string numbers, what you're gonna see that these guys are exactly the same. No matter how you express it here, they're exactly the same. So if we do sysout, right? Sysout, and we say scientific, right? Scientific equals, and we print the variable scientific, right? And then we say sysout scientific 2 equals, and then scientific 2, and then we say sysout scientific 3, and then equals, and then scientific 3, and we print this, right? Let's see what we get. Hey. Oh, because I have to do this. I have to run this one. So we get exactly the same, guys. We get exactly the same. So 3 different ways to express the same thing by using this notation here, this E here, okay? And that's most commonly seen in calculators, okay? So this returns this, right? And then we can do the same here. And this return the same thing, okay? Okay, so we have another hexadecimal floating point, right? We can have this guy here, which is a little more complicated, right? And difficult to, you know, maybe remember, right? We have this hex pi, and then we say 0x1, this is hexadecimal, and there's a 91 E, B 85, 1 EB, 1 EB, 85 1, FP1. Okay, so that's a number. And the P, right, and the P indicates hexadecimal, floating point number. Okay. So what is a floating point? Floating point computing, a floating point arithmetic is arithmetic using formulaic presentation of real numbers as an approximation to support a trade-off between range and precision. For example, here we have 0.2345. So the floating point representation is by far the most common way of representing computers an approximation to real numbers. Okay, so they have different, you know, like fixed point, low number systems, tamper, floating points, but it's basically a decimal, right? It has, you know, less bits than a double. A double has 64 bits, but they're basically the same, almost the same. But when you put a float, don't forget that you have to use the F at the end. So that's very important. With double, you don't need that, okay? The D is optional, okay? So let's print now, system out, and let's print hex pi, and then we say equals, and then has by. Let's see what it returns. 3.14. Okay, so that's another way to express by. Okay, so we can, another way to express by is just putting import, right? And then we say static Java line math. Okay, it's Java util and math. Oh, it's the other ones, Java line. And then we say pi. Oh. Okay, so it's asking me to probably do this. I don't know why this appears that. Okay, not a problem. We'll say this probably this is out. And then we say math, that pi. Right? And then we have that. Right? But this is going to give me another lot of numbers to the right of that, of the right of the decimal point. Okay. So there's another class, but not that round. But that one is a little, maybe 2 here. No. Okay, so maybe we cast 2 along. No, maybe an int. No. And then here, do this. Oh, if we do this, we're gonna get 3, probably. Yeah, we get 3. That's not what we want. But guys, that's the point. Okay, so we get here pi, right? And it's exactly the same as this one, but this one is a little more exact than the other one. Okay, guys, you understand? Any questions? You understand the decimal points? Okay. Yeah. Remember that float, you got to put an F, right? When it's a long, don't forget when it's a long, you have to put an L if it is a long number. If it's a short number like this one, you don't need to put it. Don't forget that. This guy compiles because float, a double covers a float. Okay. This guy compiles because a double covers an int. Okay. Now, if we print right here, if we print double free, what do we get? 1.0. Okay. Even if we enter 1.0. Be careful, guys. Be careful. When we get to methods and passing parameters, if you pass a double and they give you this, that is wrong because that's not a double. Okay, even though you put 1 here, but when you print it, that's going to print 0.1. Okay, you want to see it? If we put here 3, and then we print it, we get 3.0. Is that rare? The value that this number is storing is not 3, it's 3.0, because this is a double. Okay, a double is a decimal. Even though you enter this, right, you're gonna get a double.
So this is a way of converting an integer to a decimal point?
Could be. It's not conversion as such, but it converts it to a double. Okay. However, this doesn't work.
Yeah.
Right? the opposite doesn't work because a number, a double covers an int, but an int doesn't cover no, it's called double. Okay. So I think that we've seen a lot since we started today. All right. We saw all these guys here, right? So guys, I know it's hard to follow me sometimes, at least to type at the same time as me, unless you have some knowledge of Java, you can type fast. But guys, I mean that's the way it needs to be because if I stop to wait for you guys to type, everybody cannot go to the same at the same speed, and we're not gonna be able to finish the class. So guys, what you need to do is after we finish the class, at least understand what I'm doing, right? When you finish the class, the good thing about this is that I'm recording the video, right? I'm recording the video. And you can go back and watch that and reproduce yourself with your own words. And also, you can check the code on GitHub. That's very important. So you're gonna have the code, you're gonna have the video, and then you can go back and watch it. And also, you can do your own studying alone, to be able to understand the concept behind this. Okay, because it's impossible to stop until everybody, catches up in the code. It's very difficult. Okay.
Yeah, I'm gonna have to watch a video again for sure.
Yeah, if we are.
But this is all good stuff, all really good.
Thank you. If we are in a good class, in a classroom, in a physical classroom, and we have like 8 hours a day to study, like a class in a real classroom, I have all the time in the world to go over this with you guys. But online classes are more challenging because of this. You are home, it's hard to follow, but not to understand. It's not hard to understand, it's just hard to be typing at the same time as me. It's difficult. And especially, I mean, it's even more difficult when you have only one monitor. If we had two monitors, you can watch me at the same time type. But if you have only one monitor, you have to be minimizing, maximizing, minimizing, maximizing. It's crazy. But what I need, guys, is you to understand this, what I'm doing. Okay, so far, is it clear to you what we have done today? Is it clear to you?
Oh, yes, so far.
Yeah? Yeah.
No issue.
Yeah, we haven't seen anything complicated yet. You just data types, okay? Just primitive types, like float, double, integer, okay? We haven't seen shorts. We haven't seen bytes, okay? We haven't seen Boolean, okay? But we're gonna see them later, okay? Let's have a break now. Let's take a break, a 10 minutes break, and let's be back here at 7:02. How about that?
Okay.
Good?
I have a question.
Go ahead.
Are you going to upload this and to GitHub again? Yeah, I forked it already, but what you did today, you're gonna do it again? Or does it update automatically? Okay.
So it's gonna Maria. It's gonna show. It's gonna show the changes. It's gonna show here when I posted today, right? It's gonna show here that there's a new commit.
Hold on. Is it going to show where?
Here, there's gonna be a new commit. Okay.
Oh, okay, perfect.
You
Yeah,
can-
I forked the one that you did 2 days ago.
Yeah, Maria Pena and on Mara Montoya. Okay, good,
But
good.
I don't know how the updates work.
You just you see here, I pinned this
Uh-huh.
message. You come here and click on source, right? And then when
Uh-huh.
you click on source, you're gonna see this here. Okay, so you have to find my repo and just find source. So this is my repo. Okay,
Hold on.
just come to source right here.
I need to go back to Slack. Okay, I'm in source right now.
Click on source, and then you see the two packages.
Yeah, I see them.
So now you have the two
Do you
packages.
have to refork it, or once you fork it,
Once you fork it, it's only one time.
it's only one that? Okay, perfect. So I don't
We'll
have to.
update this package here because I'm creating the code under this package, right? This
Yeah, the reason why I'm asking you is because I see that you're using the same package.
Yeah,
But
yeah.
I don't know if you left what was there before, so we can continue.
I don't delete that. It's gonna stay there forever. You see? You see my screen?
Uh-huh.
When I push today, it will just update it, not remove anything. It will add whatever
Okay,
is new.
perfect. Yeah, that perfect. Thank you so much. That's what I wanted to make sure.
It just add whatever is new. It doesn't delete anything. Okay?
That's perfect. Thank
Great.
you, thank you.
So you're welcome. I'll see
Sorry
you.
about being late today. I was
Not a
working
problem.
on something else and the time just went by.
So guys, I'll meet you in 10 minutes. Okay? Thank you.
Okay, thank you. Bye-bye.
Wait, guys, let's continue. Are we back?
Yes.
So let's see now the primitives chart and Boolean. So we're gonna see we saw here in this picture that we have a char and we have Boolean, right? So let's see them now. So let's create another class, and let's call this class primitives char and Boolean. I forget that Boolean is Boolean is true or false. Okay, so we do this PSVM, and then we have the main method here, right? So let's declare a char. A char is a character, okay, and let's call it CH, right? So a character has single quotes and just a character, okay? It can be a capital letter, it can be a 1, it could be a comma, it could be a semicolon. It's just a character, okay? Like we saw in the table, right? Where's the table? Do we still have the table? See here, what's the table? ASCII code, where is it? Here, okay? That's a character, right? Anything here in this red color, that's a character, all right? So whatever we put inside that single quotes is a character, okay? So for now, we're gonna put A. Guys, this right now will not compile, okay? This will not compile, okay? It's only one character, okay? It's only one character. So this does not compile, okay? Very important. Okay. So let's declare another char, and we call it char sh1, and we say this is 1, okay? So this compiles. It's only one character, okay? Now we also have something called Unicode. Have you ever heard about Unicode? Like Unichar, right? Unicode. So we can say this. It's just in another language, okay? We can say this, and then we say this like this. Is a U0389, okay? And let's see what it prints later, okay? So that's Unicode. That's a character in a different language, okay? But it's expressed that way, okay? Now we have this, and then we have the Roman number, right? Roman number, and we can say this U216C, okay? And that's a Roman number. Now let's print char1 and say 1 equals ch1, right? We can ch out, right? Unichar equals Unichar, right? And then we ch out Roman number equals Roman number, right? Let's see what it prints. Okay. We just run it here, and then we get 1, which is this chart here. We get the Greek omega character, right? And we get number 5 in Roman numbers, okay? So here we are returning number 1, right? 1. Here, this is uppercase, Greek omega character. And this one is the Roman 50 number. Okay. So those are characters, but characters can be expressed in Unicode, right? Or can be expressed with only one character in our, alphabet or, characters in the English language or in the just Western hemisphere. Okay. Okay. So if we take, if we say omega in Unicode, so here, 0389, 0389. Of course, in programming in Java, you have to put the U at the beginning of this. Maybe we say here alpha, right? Then we get 03B1. So we say Char.
So this is a way of printing symbols.
Letters in another alphabet. Yeah.
What is next to the equal under the omega, is that a symbol or
Where?
down below? It says CH1 unicar equal and then something. Is that a symbol that is printing?
It's printing the omega symbol right here. Omega, the omega letter.
So that's a way of printing the symbols.
Yeah. Okay, so I can see this out. Alpha. And then we say alpha. Okay. And then we run that. There's the alpha here. Okay. Right. You say, I'm the alpha and the Unicode.
I put one on the chat. A Unicode on the chat.
So I am the alpha and the omega. Okay. Put it on the chart. Let me see.
On the chat, yeah. Look for the chat.
Okay, 2638. Perfect. Let's do that. That is printed. Let's see what it does. Oh, nice. That's a smiley face. Nice. That's Unicode. Correct. Good, good, good. Thank you, Maria. Thank you very much. Now, let's see. So far, so good, guys. Do you understand? Do you guys understand?
Yes, Professor.
Yeah. You know, a chart is
A
chart is only one character. Even though you see a lot of numbers here, or like 4 or 5 characters, that represents only one. That's Unicode. Okay. Unicode to express different symbols, right? And letters of another alphabet. For example, delta, that's another one. Delta. Delta will be 0394. Okay, so I'll put here 0394. Is that the one? So we can do char delta, right? And then we do this, and we say this U, right? And then we say, I like the airline Delta. And then we print this. And how do we get? What do we get? Delta. Okay. There's another one. Lambda. Lambda is 039B. So we can say here char lambda. And we say this. Right? And we can say, let's go serverless and use lambda. And then it prints lambda there. Okay. So that's how you print Unicode, guys. Right? And basically what is just behind it is just one character, but it's expressed in Unicode in a different we say notation, different way to express something, but that is a character. Okay. Don't forget that if it is more than one, it doesn't compile. Okay. Very important. Now let's see Boolean. Okay. Let's see Boolean. Now we say Boolean is representing us with the word Boolean. That is the key word. That's the type, right? It's a primitive based on what we saw in the picture, right? Boolean is a primitive that has a value of true or false, right? So we can say my Boolean. Remember, the variable can have any name you want. Now this doesn't exist. This doesn't compile, right? This doesn't compile. Let me copy this. Okay. This doesn't compile. Right? It doesn't compile. This does not compile either. Okay. Right. What compiles? This. Okay. So Boolean is true or false. Okay. And then we say Boolean, my false Boolean. And they say false. Okay. That's where Boolean stores. It's a true or false value. And then we can say now, this out. We say my Boolean. And they say my Boolean. It says that it's always true. This is logical. Okay. And my false Boolean. So whenever you have a Boolean value and then you try to print it, if it is true, it's going to tell you, it's going to give you this kind of warning here that tells you that it's always true. Okay. But it doesn't mean that it's an error or anything. It's just a warning. Okay. So now I say here, and it prints whatever value it has inside. My Boolean, true. My false Boolean, false. Okay. So far, so good, guys?
Yes, Professor.
Okay, the char and the Boolean. Okay. Any questions? No? Yes? Maybe?
We're good.
Okay, let's see something a little bit more confusing, but you're smart people. You understand it. Okay? So let's just create a class, another class, and let's call it default initialization. Okay? And let's just create our guy that we always create, right? Right? Now, I'm going to use several variables, but I'm going to use this outside the main method. Okay? So if I declare variables outside the main method, they have to be static variables. Okay? They have to be static. That's the way you do it. So I'm going to create a Boolean, and I'm going to say my Boolean. Sorry. My Boolean. I'm not going to give it a value. I'm just going to declare the variable. Okay? And now we're going to create another one, and we're going to say byte, right? And I'm going to say my byte. And I'm going to just leave it that way, no value assigned to it. I'm going to create another one, and I'm going to say short, my short. Okay? I'm going to create another one and say int my int. Right? I'm going to create another one static long my long. Another one say static float my float. I'm going to create another one say double my double. I'm going to create another one say char my char. So you can see a lot of primitives there. All the primitives that we saw in the picture, in the image, right? All the primitives here, the primitives. But I put them outside, right? Not inside the main, right? Now, what I want you to do, guys, see, guys, is I'm going to print each of them, okay? For you guys to see how these static variables are initialized by default. Because normally, you can do this, right? Right? Now, this is a Boolean. You can do this, right? And give it a value and initialize it like this, right? Just give it a value, right? And int, see, like this. And maybe this guy you can do like this, right? Something like that. Okay, like the number here, similar. What was it? The one that we had before? Like this one here. I can put a value like this one. Okay, but I'm not gonna do that. I'm just gonna leave it that way. Okay, for you guys to see the default value that Java assigns to these static variables. And by the way, this only happens with static variables. If you declare a variable inside here, right, and you try to print it, you're gonna get an error. You're gonna get an error. You have to initialize the variable. Okay. Outside, you can leave it the way it is, right? And that's gonna be one of the questions in the exam. They may put this here, and they may tell you what does it print, okay, or something like that. Okay. So I'm just gonna say my Boolean equals my Boolean. Okay. And I'm going to copy this to be faster. Okay. Right. And then the second one is my byte. Right. And then my byte. The third one is my short. and then here my short. The third one is my int, and that's my int. My long, and then my long, my float, and then my float. Okay. My double, and then my double. And my chart, and then my chart. Okay, so Java, all of this compiles, right? Now let's run this and see what default values Java gives to this. There you go. So my byte, my Boolean is initialized to false. That's the default value of my Boolean. Okay, so whenever you put a static variable outside, it's going to default to false. Okay, my byte is going to be 0. My short is going to be 0. My int is going to be 0. My long is going to be 0. My float and my double, they're going to be 0.0. It's like I show you in the other one, guys. When we printed third, my double third, that it printed 3.0. Same thing here. It is initialized to 0.0. Okay. My chart is initialized to this guy. Okay. To this guy. It's open and close square. Okay. So if you see this out, and we do this, let's see what it prints. Okay, it's a little different, you know, but that's the default of Char. Okay. Now, if I declare a variable inside the main method, okay, it doesn't give me an error so far, but when I print it, if I do this out, and I say local int, because it's local, okay, this is global. This becomes a global variable because it's outside this block. Whatever you see inside this curly braces is called a block. It's a method block. If you declare a variable here, it's only available inside the main method. You cannot, if you create a method outside, this variable cannot be accessed from another method because this variable is local. These ones here outside can be accessed from anywhere in the class. Okay, so this makes this variable global, and this one makes it a local variable. That is the scope of the variable. The scope, local and global. Okay, so now I'm gonna print. I'm gonna say local int, right, equals, and then say local int, right? And now we have a problem here. What does it say? Variable local int might not have been initialized. This will give you an error. If you're running, well, just from the off the bat, we're getting a red line here. It's telling you this is not correct. So if we run it, we get a problem here, right? Line 29, we have this problem here. Oh, because I'm missing this guy here, right? That's okay. But anyways, if we stop it here and we run it again, right? We get the variable local int might not be initialized. So for that, if we do this, right, that's a local int, right? And if you do run it now, what do we get? Local int equals 5, right?
How do you do line-by-line debugging with this application?
Remember, we have to put a point, a breakpoint. right? You put a breakpoint, and then you do here, run debug.
Ah, okay,
And
perfect.
it
Thank
will
you.
stop. It would ask me which one do you want to run. This one, it will stop immediately when it gets here.
Okay, perfect. So basically, you're
Yeah. Then you can step over every line, and just will tell you how much every variable is. What is the initialization of those variables?
nice. Thank you.
You see? So actually, the default it shows here. It shows here my chart like U0000. That's the default of my chart. Okay, but it looks like a symbol. It looks like a symbol here, right? Let me stop the debugger here. Okay. I remove the pointer here. Okay, if we run it, let me see. Here, we get this guy, but actually this guy is this, like this. That's the default of the chart, right? And it looks like this when you print it. Okay? But this is the default. Okay, so what value does the chart?
It's a no. NU is a no.
No, it's the default value. Just the default.
Yeah, but U000 it's no.
Default value. Default value. You see this one, right?
See down below.
No is for strings and objects and things, but this is the default value of the guy. All right.
Interesting.
So don't forget that default value is this one. Okay, just in case they ask you in the exam, guys. So the local int, right? And actually this one, nope, it's this one. So this one defaults to false, right? Right. This one defaults to 0. This one defaults to 0. This one defaults to 0. 0. 0.0. Okay, good. So now here, what we're gonna do, I'm gonna do this, and then this does not compile. Okay, because the variable, this does not compile. Because the variable, okay, the variable local int is not initialized. Okay, and that happens with local variables. Okay, local verbs they need to be initialized. Okay, global variables, static variables don't need to do that. Okay, they don't need to be here. Of course, I can declare here a variable, say char, my chart. Right? Right? But here, if I put it here, I have to initialize it. Some sort of that. Do you have my chart already here? Yes, it's right there. So I have to put my chart 1. Okay. So here I can do this, but it would not be static. Okay. When we get to statics, we will understand what this means. Okay. For now, just keep it that way for you guys to understand. So you guys understand the initialization of this, right? I didn't put a string here because a string is not a primitive. Okay? This is not a primitive. That's why I'm not going to put this string here, right? So now, if I just print my string equals my string, right? So now I get null. So this is the the default value of my string. But my string is this not in this group because my string is not, this is not a primitive. Okay, the primitive is the ones that we saw in the image that I showed you guys. These are the primitives. Okay, it's a very common question that people ask you in an interview if a string is a primitive. So you say no, it's not a primitive. Okay, string is a class. Okay, as you can see, string begins with capital letter, which makes string a class, right? You see the other types, they're red, but you see string is blue, so string is a class. Okay, good. And by the way, string is also an array of characters. Okay, when we get to arrays, we will understand that better. Okay, so we say static object, and then we say object. Let's see what it prints. We have any issues here? Okay, yes, I remove this. I don't need this. And then I print it. And the object, oh, I have to print the object, sorry. So I'm gonna bring this back. I'm gonna say my object. And then say my object. And change the name here and say my object. Okay, so now if I print it, I get null as well. Okay, because by default an object is null. Okay, that's why if you don't give it a value, you get a null pointer exception because the object needs to have a value. Okay, but by default an object is null. And let me put it here because this is not a primitive either. Right? Okay. Are you understanding, guys?
Yes, yes,
Is it clear to you guys?
it is.
Okay, so this is initialization of your variables, right? And by default, they have a value when they are static. If they are inside a method, they have to be initialized. Okay, good. Now let's see another topic. Let's see variable scope. Okay, this is the other one. Okay, so variable scope. Is Anand here? Anand, are you here?
Yeah, I'm here.
Oh, yeah, good. Good. So, by the way, thank you. Not thank you. Congratulations on your IBM certification.
Thank you. Thank you.
And for your solutions architect as well.
Thank you.
You're killing it. That's good. Good. So we're going to see the variable scope here, right? So I'm going to create a static variable here outside the main method. And I'm going to call it my new int, okay? And I'm going to just initialize to 0. So that's an integer named my new int. And it has a 5, number 5 as a value assigned to that variable. Okay? Now I'm going to create another variable, right? And I'm going to say my local int, okay? And then I'm going to give it a 10 value, okay? Now I'm going to create a block. This is a block. This is valid in Java. You can create a block with the curly braces and, you know, and do things inside that block, okay? Now I'm going to create another block inside another block, okay? And I'm going to say int, right? My other int, give it a name 10, right? And then I'm going to create another block, right? And say int my other int2, and then give it a number, right? So now Ascii here, we're going to say int my other int equals 20, right? And I'm going to say int another int, which is 30, right? And then after that, I'm going to print my other int and I'm going to say my other int, right? And now I'm going to say sysout in code block my local int equals my local int. Okay. So now I close this. This is closed here, right? And now I'm going to say sysout my local int equals my local int, right? And we're going to say sysout my new int my new int. Okay, so let's see what it prints. Let's see what it prints. Okay, let's see. So let me run it. Okay, so we have a block here, right? A block. Whatever variables that you create inside this block, they're not accessible from the outside. They're only valid in this block. Okay? Only valid in this block. So here we have my new int. It's right here. You see my new int here? It's a global variable. That's why we can access that variable from here. Okay? So whenever I am either here or there, if I create another method and I say public static void print my new int, right? And I do this and I say sysout my new int, I can access that. Okay? And I can say here, let us call the method and say print my new int. So I'm calling the method, right? If I say this, I can still get a value here because this variable is global. It doesn't matter where I am, even in the main method or in the print my new method, it doesn't matter. This my new value, my new int value will be accessible from anywhere because it's a global variable. It's a member variable here. Okay? It's just outside the methods. If you put them inside a method, so if I say here, if I just say here, for example, which one is inside a method? My local int. If I do this, that variable doesn't exist. Why? Because I created the variable inside this method. It's right here, right? It's right here. That's what determines the scope of a variable. A variable will have scope based on whatever is declared. If it is declared in a block, guys, this is a block. From here to here, that's an entire block. Whatever you declare inside is not global, it's local. If you declare outside a method, like here, as a member field of this class, then it becomes global. Okay, so I'm gonna leave this guy here. It's my new int. Okay, my new int. Sorry. Right, that one is accessible. Okay, so I can put here accessing my new int equals plus from print my new int method. Okay, so if I print that, this is what I get. Accessing my new int equals 5 from my print my new int method. Okay, so now this guy here, my other int, right? It's right here. You see here? So it is in the same level of this one, right? And my local int is outside this block. Okay, it's right here. It's like a global variable of this entire block. Okay, now these guys here can only be accessed whatever they are. So I can access this guy here and says this out my other int. You see, because I am outside the block. Now I cannot say my other two. You see here, this is my other two. This is not available outside. When will it be available? If I put it inside here. My other two. It's just the scope, guys. It's just the scope of that variable. Okay? This one can also be accessed from here. Right? I can say another int equals, and then I can say another int, right? Because they are in the same level, in the same block. What is the block? This guy here. That's the block. But these guys here are entirely in a different dimension, okay, in a different block. This one, it's outside this block. That's why I can access it from here. And this one is inside. Do you guys understand what I'm doing here? Do you guys understand?
Oh, yes, Professor.
Yes.
Huh?
Yes, yes.
So let me give some examples. Don't compile. Let me put it here. So I say 2, right? This does not compile. This does not compile, right? So because my other int 2 is out of scope, right? You get it, guys? Now, this,
Yeah, yes.
this which is this one, right? I'm sorry, this one would not compile because my other int is out of scope, right? You see, it's out of scope. It's inside this block, and I'm trying to print it outside the block. It doesn't work. Okay? So you have to be in the block to be able to access the variable, or you have to declare the variable as a global variable so everybody can access it. It doesn't matter how many methods I create here. It doesn't matter. You see, it doesn't matter. Still, I can access that variable. You see that doesn't give me an error. Okay, so I can call this method. By the way, this is a method call. Okay, I'm calling the method, right? The free method that I created, right? So if I print that, I get the same variable 3 times, okay? Because this is a global variable, okay? It's a global variable. That makes it accessible from anywhere in the class, okay? If I want to access it from another class, then I have to make it a public guy, right? But the way it is now is not accessible from that class. Okay. The only way that I can access that variable is if I just do it the other way. But the other way, I'm not going to teach you now. In another occasion when we study static. Right now, for now, static is not a content of this lesson. Okay. Guys, if you have any questions, let me know. Okay. We're seeing here the scope of a variable. The scope of a variable. Okay. Okay. So you can have several variables here. Okay. Any questions? Can we continue?
Yes, Professor.
Yes, yes, you can.
Okay. So now we're going to see ordering elements. Okay. Ordering elements. It's very important that you understand this, guys. Okay. Now, let me create another class here. And I'm going to call the class ordering elements. Here's the main method, right? So first of all, the first line that we have here is the package. Okay, the package. You have to understand that the package is the first element of a class if you are using a package. Okay, this is the first element. After that, we have the imports. Okay, very important. Imports. Okay. Sorry. So in this case, we are importing UT class, right? We don't need it. We're going to need it later. But you have to understand that imports are super important. Let's create here a list, right? A list. And you see, immediately imports list, right? So list equals new list, new array list, right? And then we have this. We're going to see array list when we get there. This is a list of elements of different types. Well, in this case, is of the same type, and the type is string. Okay, so maybe like this. Okay, so then you will have to use the method list.add, and then you put Dunieski. It has to be a string, okay? And list add. Those are elements of the array, right? And can call this, right? And then we can say for. This is a for loop. We're gonna see when we get there. For string name and list give me the name, right? Now if we print this, Dunieski and Carlos. Okay, this is just an array of names. Okay, you may have the same as an array of integers, right? And then you will have to put, instead of a name, you have to put a number. Okay, and then the type will have to change, right? So we can say for every number, right? And then we print the number. Now we print this, and then we get 1 and 2. Okay. Okay, but we're gonna get to list later. this is for you guys to understand that packages are the imports are the second elements of your class. Okay? And then you have classes like class, for example, class, my other class, right? You may have another class and call it another class, right? So classes are the second element of your program, right? Of your class. The name class is the second element of that particular class. Okay, and then you have, for example, static declarations, like this one, for example, right? Or elements here that are member elements. Int my int, right? Equals 10, or we say static. Let me format this, okay? I'm just formatting this. Okay. Okay. See, my int my int equals 10. Okay, member fields. Okay, outside the main method, or static string, for example, string my string Duniesky. Okay, that's an example. Okay, so we have packages, imports, classes, and then inside the class we have the member fields or the static fields here, and then after that we have the main method. Okay, that's the order of the elements in a class. Don't let yourself be confused if they put something that is not this order. This is the correct order, guys. Okay, this is the correct order. And then you can declare inside the class anything like other than that is maybe something like just int another int equals 10. Okay. Now, guys, if you try to put a method inside a method, you're gonna get an error. So this will not work. This would not work. You see, expression expected. This would not work. Why? Because this method is declared inside this one. So you would have to do it outside. So you have to come outside this guy and then put it here. Okay? Methods cannot overlap. They cannot be used inside each other. Okay? They have to be used outside each other. Okay? The only thing that can be inside, method that can be inside a class. Yes, they can be inside a class, but not one inside the other. Okay? Everything else can be inside the method, but not a method. Okay? So don't forget this order. Okay? Don't forget this order. PIC, right? Don't forget that. Package, import, class. Okay? Remember this. Remember this. Okay, this order.
I have a question.
Go ahead.
So the class, can you go up on this to the top of, okay, these classes that you have declared up here, they're only accessible from within this package, right?
Correct. Correct.
So if I have another package that want to access my other class, it's not going to be able to do that because it's not a public class.
you have to import the class. So you have to do this.
Uh-huh.
The other one is com, another package, and then animal. Okay.
So what would be the purpose of having this declaration of these two classes like that on the top?
If I do here animal,
No, yeah. No, the top ones. I'm talking about the top one. Class my other class, class another class. What's the
it's not
purpose?
the same package. It's not the same package.
But it's only accessible within this package,
Yeah, maybe you want
Correct.
to create.
Yeah, because
right?
yeah. They are in this package. Okay. Now, if you want to import these classes to another class, you will have to do this, like I did here.
No, but if I were to access all ordering elements from within the package,
You have-
com.another package.animal, right?
Yeah.
Or, I'm sorry, com.another package. I can do that because it's a public class, but I won't be able to do that because the other two are not. I won't be able to access my other class and another class from another package.
Correct.
Okay, thank you.
You can access this class by creating an object.
Professor, these two class, my other class and another class are private.
Let us try. Let us see it. Do I have an error here? What is the error? Where's my arrow here? Okay, this one. Animal. Animal equals new animal. And then this. Okay.
I mean,
We just create an object of that class animal. Yeah. Let me just go to this package and create another class. Right. Let me create a class and I call it access another package. So now I'm gonna see, I'm gonna say PSVM, right? And I'm gonna say, what's the name of the class? What's the name of the class? My other class, right? One moment, let me see here. Where's the guy? Okay. You see?
That's interesting.
You see? It's not a public class, and MDC cannot be accessed from outside the package.
Yeah.
Okay. So that is a protected class. By default, it's protected. That can be only accessed within the same package. Another class here can access it, but not the other one. Okay. So you will have to make that one public. Okay. And
Okay.
it may give you.
So if you make it public, it's the same thing as ordering element.
Yeah, it may give you a problem because it has to be created named in with another that Java. Okay. And the one that is my other class, the one that is that Java is the ordering element.
I see.
This one can only be accessed within this guy.
So in other words, it's almost like a private class within the package that has public classes as well.
Yeah. Okay. It's protected. Okay. It's not private. It's protected. Only elements in the same package or a subclass can access it. Okay. So this is the same as this. Okay.
Oh.
Yeah.
Do we have the private access modifier in Java?
Yes, you do have that. Yes. Yeah,
by default, it's protected. By default, If you don't put it,
Let
just put it.
me try to access that class from here. Okay, in the same package,
Can
right?
you, yeah, that's what I was going to ask you. Can you access it within the public class? Because it's declared in the same package.
Okay, so that one, we have 3 related problems, and this is in the other access one. Okay, this is incorrect. Okay, so let's remove that. Right? Because this is another package. This one can access it. Create an object here, and it works. Okay, we are in the same package. Now, let me do something. What if in this guy, what if I say that this class extends my other class? Import class. Okay. It's not a public class. I get the same issue.
Yeah.
It's not a public class, you know? Okay. Make my other public class public. So I made it public, but I get an error here. It should be declared in a file other name. So
it's not a class. It's not a declared class.
Basically,
public class in one file, one class file.
Correct. So I have to do the same as this. Do the same here and create a class, and it would get that Java. This one doesn't have that. It's just a class that I declare inside this class, .java. It's a class
in that package.
In that package, yes. But it's not a class that I created like Java class like this inside the package. It's just a class that I declare inside here. Okay?
I think that has its uses, right? Because if you were to...
Yeah, if you want to work in the same page,
exactly.
you can use that. Okay? But when we get to classes, we understand this better. We're just now trying to understand the order of the elements in a class. Okay? Don't forget these guys. Okay? Package imports class. Okay? So we will have one or more than one. But the classes are the third elements of this class here. That class.java file.
It's package.
Package. Just remember PIC. PIC. Package imports class. Okay? And they may give it to you mixed, you know, like a mess, chaotically. And then you have to, you know, they say that that's not correct. The correct order is this one and this one, this one. Okay? So that's very important. Okay. Any questions, guys? So I have to fix this guy here. This is not correct. I'm going to delete this guy. I don't need it. Okay. All right. And then the error is gone.
So when should we use the private access modifier?
Usually, it's very rare to see that in classes, right? By the way, this is not a public class. This is by default private, right?
It's private?
Yeah, it's private, not protected.
Okay.
Not protected.
Okay.
It's private by default. So it's not a public class, okay? And it changes the color as soon as I use it.
Okay, got it.
So now I can say, for example, here, create a method, right? And say public, say public void, and print result. Right.
So
I'm gonna return here an integer, right? And I'm gonna say say here integer first equals 1, integer first equals 2, and then I can return first. Sorry, I put the same number, same name, sorry. Second I can return first or second, right? So I'm just returning the sum of these two guys, right? So I can come here and say maybe my other class, sorry, my other class, my other class, an object, right? Equals new, my other class. And then I can say my other class yeah, it makes it private completely. Maybe if I do these guys here, if I say maybe public, yeah, makes it private. But I don't like to work with classes inside classes like this. I don't like this. I prefer the other way, which is the traditional way. Like this is very commonly used in exercises like this to show that the order of classes, but I prefer to work the traditional way, like creating another class outside and just calling that class. Okay, this public class here. Okay, but you know, you can create another class here from the public one. You can call these ones, but from a private to a private, it's not possible. Okay, I can create another object here and say, for example, my other class, and then call that print result. I delete that. Oh my gosh, I should have done that. Should have done that. Let me put it back again. Okay, here, good. So I'm gonna call it from here, and I'm gonna say my other class, and then I print the results, and I get the result from that class. So I created an object, right? Remember, yeah, on Tuesday when we created the setters and the getters, remember? This is similar. I'm just printing a method that is inside this guy, okay? And then, as I'm returning a value, right? Because I'm not printing anything here, right? I'm not printing anything. So if I just call that method, I'm not gonna get anything. So what I have to do is just store that value in a number. So whatever the method returns here, right, is returning a value, and the value is 3, correct? The value is 3. So whatever I return in that method is going to be stored in this variable, and then I can say sysout, the number is number. And guess what? It's going to print 3. Okay. So if I run it now, I'm going to get the number is 3. You see? Because I'm just creating a method, a public method in this class. And then right here, I'm creating an object of that class, correct? Creating an object to be able to access that method. Okay? Right? So what if I do this? I cannot do that. Static class. But I can do this. Right? I made this guy static. And then I don't need to do that anymore. Right? What I can do is just put my other class. When we get to static, we will understand that when we have a static method, we don't need to create an object. Okay? When you have a static method like this, you don't need to create an object to access the method. We just put the class and then you get the method. But we will understand that when we get there. Okay? For now, let's leave it the way it was, right? And now let's put here the object. Let me copy this guy, right? And let's do this, right? I remove the word static from here. Right? Now we don't get an error. And let me put this guy here, and let me just comment it out and say, this is used only if the method print result is declared static. Okay. And then we just access the method by putting the class name. We don't have to create an object here, an object to be able to access that particular method. Okay. So let me put this inside the method. So you see, guys, that it doesn't work, right? So we put here, this does not compile because my method is declared or is created inside the inside the main method, and methods cannot overlap. Okay. Guys, I would delete this for now. I don't want a list to be here because I don't want to confuse you. Okay, so I would remove this link from here, right? And I can remove this guy from here too, right? Perfect. Okay, and I will remove this guy from here. Well, I can leave that there. Okay, so don't forget the order of these elements. This is very important, guys. Very important that you know the order of the elements in a class, right? We have the import and the package, input, and the class. In this case, we have 3 classes. It doesn't matter, class after class, right? And then we have the declaration of whatever is in the block, and then the main method. The main method doesn't have to be here. The main method can be after the other methods. You can declare any method. Java doesn't care about that. Compiler will find the main method, whatever it is, right? It's just the major portion of the class is the package, the import, and the class. Okay? Don't forget that you may have several imports here, right? Remember when I have the list, if I declare a list, then I will have this import here. Don't forget that if I do this, right? Date, right? I will have to import that class, and then I will have another import, right? It's right here. So I will have 2 imports. And what would they ask you to do in the test? They may ask you to remove the unnecessary imports. So they may put imports that are not needed. Okay, so you will have to know which one is needed, which one is not. Okay, if I'm not using any date here, right, the import will disappear in IntelliJ, but they may still keep it in the exam to confuse you. If I don't have any date, I don't need that import. Okay, the import is only there if I need it. If I don't need it, it's not there. If I remove this animal class, right, this animal class, if I remove it, the import will disappear. It's gone, right? That's the good thing about IntelliJ. But guys, IntelliJ is not going to be with you, okay? It's not going to be with you in the exam, okay? What do I have here in the animal class? What do I have here? Do I have anything that's more important? Print results. So I can just come here and just do this, right? And say animal, print results, right? I just created an animal object, and then with that object, I can bring and print this method. So I can say here and say animal class, okay? Beautiful, animal class from this guy here. So what if I do this, guys? What do you think is gonna happen if I do this? Do I have to create an object in this class? Look at this. Immediately I get an error, okay? So the solution for this is you can do this, right? And simply do this. And pin. So problem solved. Okay? So I can just come here and then I get exactly the same result. Because I went here and declared this method static. So when we have a static method, we don't need to create an object to just access the elements of that class. By simply putting the class name, then it's easy. Okay, so I can put here the same thing. I can say this is used only if the method print result is declared static in the animal class. Okay, good. So let me just comment this, right? Let me just leave it the way it was. Come here to animal, remove static, right? And save it. Come here again and do what I did before. Animal dot print result. And then I print it and I get the same result here. You see, guys, are you understanding? Are you seeing the beauty of Java? Are you understanding the beauty of Java?
Beautiful.
You see? I think that we have covered all we have planned for today. Do you guys have any questions?
No, not now.
Nope.
Nope. So on Tuesday, we're going to study primitive wrappers. We're going to understand null a little bit more, null, okay? We're going to see the benefits of Java, and then we're going to jump to the operators, arithmetic operators, numeric promotion and casting, urinary operators, assignment operators, things like that. And we're going to get into more things. If we hadn't had, well, we did just, spend all the time that we spent on Tuesday, we would have finished module 1 already. Okay? But we're going to be okay. Okay? And then we'll continue on Tuesday. Guys, my advice, go over everything that we covered today and Tuesday. That's very important. That's very important.